Here we're going to find the radius and interval of convergence of the sum as n goes from 1 to infinity of n factorial times x to the n divided by 1 times 3 times 5 times all the way up to 2n minus 1. This is one in which the number of factors in the denominator will increase with each successive term. As before, we're going to proceed using the ratio test. So the limit as n approaches infinity of the absolute value of n plus 1 factorial times x to the n plus 1 divided by 1 times 3 times 5 times dot 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 times 2n minus 1 times the next factor would be 2n plus 1. That all is the n plus first term times the reciprocal of the nth term, 1 times 3 times 5 times dot 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 times 2n minus 1 divided by n factorial times x to the n. I'd like for you to take it from here. I'd like you to find the radius and interval of convergence, and please go ahead and test for convergence at the endpoints. Come back when you are done. Using the ratio test, we've got the limit as n approaches infinity of n plus 1 factorial times x to the n plus 1 divided by 1 times 3 times 5 all the way up to 2n minus 1 times 2n plus 1 times the reciprocal of the nth term, 1 times 3 times 5 all the way up to 2n minus 1 divided by n factorial times x to the n. All but one factor of x divides out. N factorial divides out, leaving us with a factor of n plus 1. And then all of the factors in the denominator divide out with all of the factors in the numerator except for the 2n plus 1 in the denominator. Therefore, we have the limit as n approaches infinity of n plus 1 over 2n plus 1 times x in the absolute value. The n plus 1 over 2n plus 1 will have a limit of 1/2 as n approaches infinity. So this becomes the limit as n approaches infinity of x over 2. That'll converge in the absolute value, excuse me. That'll converge if the absolute value of x over 2 is less than 1, which means that absolute value of x is less than 2. That gives us our radius of convergence. It also gives us the endpoints of our interval. They are -2 and 2. It looks like I had an error here. I wrote down that I tested the endpoint x equals -2, but I could see in my work I tested the endpoint x equals 2. It's actually the same result both times. Folks, if you tried using the ratio test to determine convergence at the endpoints for this, you probably got frustrated because you end up with a limit of 1 and then it was inconclusive. Here though, if we let x equal 2, then we have the sum as n goes from 1 to infinity of n factorial times 2 to the n divided by 1 times 3 times 5 all the way up to 2n minus 1. In this case though, as it turns out, the limit of the nth term that I just read out becomes the limit as n approaches infinity of 2 times 4 times 6 all the way up to 2n. That's what happens when you take a bunch of factors of 2, we have n of them, and multiply them by all the factors of n factorial. You end up with a bunch of even numbers. In the denominator, I have 1 times 3 times 5 all the way up to 2n minus 1, a product of a bunch of odd numbers. Now, it doesn't matter that they're even or odd in particular. What does matter is that the limit of this expression is not equal to 0. If we had let x equal -2, then every one of these factors would have been negative. We'd still have a limit that's not 0. Therefore, this diverges for x equals plus or minus 2 by the test for divergence. Now we can come back up here and say then that our interval is the open interval from -2 to 2. We already established that the radius was 2. Now back to this frustration that I mentioned. If you had tried to use the ratio test to test for convergence at the endpoints, and you may be looking at the work that I did saying, well, how did I know that I was supposed to check that the limit wasn't equal to 0? I don't actually think that a lot of people would have thought to do that. I wanted you to have the experience of trying something but it's kind of with a safety net here, right? Because when you hit that wall, if you did, you were able to play the video and then see how it works out. At this point now, what I'd like you to take away is that this is a strategy that we can use, and when to use it, I don't know, it's a case-by-case thing, right? But it didn't seem like any of the tests that we had would work, and so the idea of just checking, hey, is the limit even equal to 0, maybe will now be in the forefront of your mind.